Hi, everybody. Welcome back. In our discussion of lighting, it's now time to talk about how we provide light to our interior spaces. And it turns out there's two major ways. One is daylighting, and the other is artificial lighting. We're going to cover daylighting today, and artificial lighting will be our topic for next week. So as we talk about daylighting in this video, we'll find out what it is, why we use it. We'll talk about the nature of daylighting and some of the design goals that are appropriate. So what is daylighting? Well, it's a pretty simple explanation. It is lighting a building or a space with the sun instead of electric or artificial lights. Historically, daylighting was dominant in every building, but with the advent of inexpensive artificial lighting, all right, daylighting has reduced immensely. But you as a designer should account for it in your building. Why? Daylighting has huge benefits. There's psychological benefits, aesthetic benefits, and also practical benefits. Let's talk about the psychological benefits. We as humans are we have evolved with the sun, and the daily or circadian rhythms of the sun are really built into our bodies, as well as the seasonal rhythms of our earth turning and the different ways that the sun interacts with us. All right, so we have huge psychological benefits to daylighting. And in fact, there's been many studies that show that workers are more productive, students learn better, healthcare patients heal faster, etc., when they are provided with natural light. So let's talk a little bit more about those sustainability goals. Remember that our very first goal was to reduce energy use, and daylighting is a huge way to do this. So if you're providing light using the sun, it reduces the energy required for artificial lighting. And let's also tie in the heating and cooling, okay? Because it turns out that adding daylighting can reduce your energy consumption also for heating and cooling. It is cooler and higher efficacy, all right, than electric lighting in the summer, and you can actually use it for passive heating in the winter. Let's talk about the nature of daylight, its sources, where it comes from, and also variability, which is a key factor in understanding daylighting. So where does daylight come from? The easy answer is, of course, it comes from the sun. All right, but take a look at this illustration from your textbook. Direct sunlight or sun shining like a beam landing directly in your room is actually only one way that daylight can enter your space. All right. The next one is from clear sky. So just a bright, clear blue sky will add a lot of light to your space. And you'll see this especially in rooms with north-facing windows that will never get direct sunbeams into them, but still can have a whole lot of light just from the clear sky. A related concept is light from an overcast sky. And this is light that's coming from the sun, is bouncing off the clouds and then entering your space. And it's got a totally different quality than that clear sky light or the direct sunlight, okay? Because it is soft and diffuse. While we're talking about reflected light, light can also be reflected from surfaces around your building. All right, and so we see that here, it's being reflected off the ground, and in this illustration over here, it's being reflected off a nearby building. Right? So you can see that the daylight can come from many different sources, and they each have their own unique qualities. So in general, as you may or may not know, the sun rises in the east, it sets in the west, and it varies with the seasons and it varies with latitude. All right, and I've placed in your module another video that kind of walks you through these different changes and the rhythm of the sun throughout the year. And let's finish up with one final illustration of the nature of daylight, all right, before we move off of this particular topic. And here we see in color plate 16 of your textbook, remember that the color plates are those section right in the middle of the book, all right, is a photograph of a lobby of a museum in Texas, and it's demonstrating the different qualities of daylight. So we see this section in the on the ceiling, and these are light fins, all right, and they are diffusing the daylight into the space of the building. But there's two different colors. There's these white ones and the blue ones. What's the difference? The difference is this bluer section with cool lights has a shadow cast on it above from a higher part of the building. All right, so it is only catching the clear skylight and letting that into the building. And so you can see that that has a very cool quality. As opposed to this very bright white section, all right, that is catching the direct sun, and therefore it's a full spectrum light, and you can see that it's very white compared to the cool clear skylight. So for our last topic today about daylighting, let's talk about daylighting and heat. All light is radiant energy. Remember that whole discussion about the electromagnetic spectrum. All right. And as it bounces around your building, it is eventually absorbed by the objects as heat. All right. So it will add heat to your space. But it turns out that we can measure the efficacy of daylighting. Remember that efficacy was the light output, or how much light is being provided, per the electricity that's being input to the light. All right, but we can make the same measurement with daylighting by measuring the heat output. All right, so these are equivalents in lumens per watt. Those watts get converted to heat. And it turns out that at the same illumination level, the same amount of lumens, daylight is cooler than electric lighting. All right, and so that's why we said at the beginning of this particular video that daylighting is part of your sustainability strategy in the summer, all right, to reduce the cooling load in your building. But there's a big problem with daylighting, and that is controlling the amount of daylight entering the building. All right, that whole discussion about efficacy was dependent on there being the same amount of light, but often there's too much. So you need to control the amount of daylight, the glare, control excessive brightness, and therefore control the heat. So there's a couple of rules here or guidelines for how much daylighting you should provide to your space. Let's start out with the rule for summer. You want to provide only just enough daylight so that your electric lights can be turned off, not very much above the minimum desired illumination levels. Right? Don't provide too much. You also want it well distributed. You don't want any hot spots and dark corners. All right. So then in winter, you want as much sunlight as possible if your building needs heating, which most of them do. All right. Do watch out for glare and excessive brightness. Again, you do want to spread that light or distribute it as much as you can around your space in order to be able to use it for task lighting. There is a little caveat there. There are some buildings that don't need heating. All right, they are internally load dominated in that the activities inside the building actually produce as much heat as that building needs. Okay, and often these buildings are located in mild climates, so they didn't much need that the heating in the first place. All right, if you've got a building like that, follow the summer rule all year round. Right. And finally, we can't talk about daylighting and heat without talking about low E glazing, or another fancier term for it, spectrally selective glazing. All right. This is going to emit light but keep out the heat. All right. It's amazing technology. And I've placed some resources about low E glazing in your module so that you can learn more about this piece of it. Thanks, everyone. When you are providing light to your building or to your space, you can use daylighting or electric or artificial light. Often you use both, all right? In this week's module, we talked a little bit about daylighting, and next week it is going to be all about the electric or artificial lighting. Thank you.